So far we went over two methods in the order of magnitude estimate, the index based and cost capacity. And in problem 2, we use both to estimate a water treatment plant project. In the real situation, there are many other adjustments needed when we estimate a new facilities. And what are the adjustments needed? Here, I list the 6 conditions to be considered for cost capacity estimate that we discussed earlier. For the project, the reference, something special we need to exclude in the historical data. We cannot use the rough actual cost of the project without considering what are the local characteristics that may not be applicable to a new project. Let me give you an example. The project in problem 2, we do that the reference project in California. So the local condition in California, as you aware, that is the when you design the water treatment plant, we need to consider the earthquake, the seismics, etc., and that may put extra cost for the seismic response for the water treatment plant. And that if you bring that project back in Tallahassee, Florida, we don't have a earthquake, then that special cost need to be excluded. So that first condition, we have to exclude the special local condition in the reference project, the historical data. And then we determine the new facility cost based on the specialized cost or capacity. So we use the cost capacity equation in the second step to determine the new facility cost. And as the reference, the historical project built at different time compared to the new facility, we need to adjust for inflation, something we did before with the index, or we can use the inflation rate that apply in problem 3, going to show you in a few minutes. And we adjust for the location. As you see in problem 2, it costs more to build in California, Santa Rosa, than in Tallahassee. So you have to adjust for location. The fifth step, we need to adjust for different regulatory constraints. Just like EPA, Environmental Protection Agency, the requirement for environment will increase over time to meet the, protect the environment. So with that, the regulatory change, the process, the cost involved for the project may be increased to respond to meet the new requirement from the regulatory, or even not only the environment, it also in structure. You see the climate change, things like that will make more severe weather, the windstorm, etc. So design the standard change, the wind load change in Florida over time, that also need to have extra cost. So adjust for different regulatory constraint changes over time. And the last adjustment, the sixth one, if we adjust for the local factor for the new facility, exclude in the first step, exclude the local condition for the historical. We talk about the earthquake. Now build in Florida, no earthquake, but then the hurricane. So we have extra cost for hurricane, where the project in California, we don't need to consider the hurricane over there. So with that, 6 adjustments needed to do the real estimate using the cost capacity. And that I'm applied in this problem 3 here. And this is a oil refinery plant. So it measured capacity barrel, BBL per day, barrel per day. A total construction cost of the refinery of production capacity is 300,000 barrels per day in El Paso, Texas. Completed in 2009, and was the cost is $150 million. It's proposed that the similar refinery with the production capacity of similar process, with capacity of 200,000 barrels per day, so it's less capacity, 66% capacity, compared to the reference historical project in Texas. Built in Northport, Florida, for completion in 2014. And with the additional information below, make an order of magnitude estimate. The first, they give you the total construction cost in El Paso, Texas, that will have an item of 10 million for site preparation that is not typical for other projects. So we have to exclude that in the historical data. The size variance based on the exponential rule, so that we go to step 2, we determine the new facility based on the cost capacity ratio. Inflation given, so that the adjust for inflation, bullet point number 3. Locations for El Paso and Texas and Northport, something we did in problem 2. We have a location factor table. Here it's given. If it's not, then you go back to the reference to get that numbers. El Paso, 0.77, and Northport, 0.88. So it apparently built in Northport is more expensive than El Paso. And then new air pollution equipment in Northport plant that have extra 12 million in 2014 dollar. And the contingency for inclement weather, just like hurricane, etc. here at 1%. So that we have to consider all of those factors to do the estimate in here. So let's start with the first one. First step first, and you can see number 1, we have to typical cost excluding, find out the typical cost after we excluding special item in El Paso at El Paso, Texas. So what does that mean? The original cost is $115 million, $150 million. Special item for cycle preparation in there, $10 million, and not typical in other projects, so it blue. So from the historical, so it $140 million. And then go to number 2, we use the cost capacity to adjust. So adjust capacity, and that it will be the that you can see the cost there is 140 million. Adjust for the capacity in Northport, the new facility, 200,000 barrel per day. For in El Paso, Texas, 300,000. And the cost exponent in this case, M equal to 0.6, so you have that at 0.6. So from that we had $109.8 million. What does that mean? The project still located in El Paso, Texas, with capacity 200,000 barrel per day. It costs about 109.8 million. The third step, we need to adjust for inflation. Adjustment for inflation, and that lead to the costs in 2014 dollar. And for this one, the equation for the with the give inflation, you can get the 109.8 million, and equation very simple. It will be 1 plus inflation rate, inflation in here, 5% in that 10 years, right? So it will be 0.05 interest, and from the project complete here 14, and the El Paso, Texas complete in 2009. So in that it will be 5 years difference. So we have to adjust the power, it will be 5 years. So where that 5 years come from? That it will be 2014 minus 2009. And from that one, we get the adjustment is $141 million. And we have to adjust for the locations. Adjust for location because bring the project back to New Northport, Florida. So adjustment for location. So 140.1 million location. El Paso 0.77, Northport 0.88. So we have 0.88, the new facility in Northport, reference facility in El Paso. From there we get this one, 160.1 million. And then the next step, we need to adjust for the different regulatory constraints. In this case, the new air pollution equipment required for the new requirement. So here we have number 5. We have adjust for the new pollution equipment. New air pollution equipment, and that for the new facility. So from that we have the at Northport, so that we have 160.1 million plus that new facility, new equipment, $12 million in 2014. So it's the same dollar at the same year, so you can add them. So it will be 12 million. So the total is 1.72 million. And then adjust for the local factors. In this case, they have the contingency cost due to inclement weather delay will be increased by the amount of 1% of total construction cost because of the unfavorable climate in Northport compared to El Paso. So that one, the last adjustment for the constraint. So adjustment for contingency due to the inclement weather. And that will be the last thing we do. 172 million, and the contingency 1% of the cost, so you will have 1.01 plus 1% more, so it will be 173.8 million. What does that mean to build this project? 200,000 million or 200,000 barrel per day oil refinery plant in Northport. We need $173.8 million with this. So from that you have an additional practice problem 4, similar to the problem 3 we did, and the 2 problem in the textbook 5.3 and 5.4, all solution of this available on Canvas, and practice on your own.